Hello, everyone. My name is Jeff. Welcome to Crosstalk Live, Leviton Network Solutions webinar series. Today's topic is Achieving 400G, the technology, infrastructure, and design strategies for making 400 gigabit Ethernet a reality. This one-hour presentation today gets at what is involved in creating the right ecosystem for 400 gig Ethernet and the options data center designers have. Topics will include market forecasts for 100, 200, and 400 gigabit Ethernet, the latest transceivers, form factors, and active equipment, multi-mode versus single-mode optics, and cabling migration strategies that prepare for 400G. Our presenter today is Gary Bernstein, Leviton's Senior Director of Global Product Management for Fiber and Data Center Solutions. Gary has more than 20 years experience in the communications industry with extensive knowledge in the fiber cabling infrastructure. He's also a member of multiple TIA committees and IEEE task forces. Gary?
Thank you, Jeff. Appreciate it. Welcome, everybody. Morning, afternoon, wherever you might be today. Appreciate taking the time out of your schedule to join us today. So as Jeff mentioned, I'm going to talk about 400 gig. Hard to believe 400 gig Ethernet is actually here, but that is true. So as Jeff mentioned, here's kind of the outline. I'm gonna go through, kind of talk a little bit about just cloud computing overall and the forecast with that. Look through overall latest updates on Ethernet speeds. We're going to go through kind of a brief overview of the 400 gig active equipment, the switches that very recently got introduced this year. Looking through transceiver options, what are the options available today on 100 gig as well as the 200 and 400. Multi-mode, single mode, some of the options there. And then I'll go through some use case scenarios for 400 gigs. So it could be a switch to switch and switch to server breakouts. So hopefully you guys will pick up a few things here. Starting out, I wanted to go through, just talk about the global the cloud traffic, right? This is from the Cisco Cloud Index. They publish this every year. This is from end of last year's data. And really, as you know, no surprise, right? Bandwidth is growing, and this just kind of shows specifically in the cloud that it'll grow over 3x from the report finished up in 16 going over through 2021. So you see the constant growth year over year. And then the forecast is by 2021 for 95% of all traffic to be cloud-based, up an increase over 82%. So again, still, so a lot of cloud traffic that we're seeing going that way. Next thing, just to dive in a little bit deeper on the hyperscale data centers. So this is also from the Cisco Cloud Index. And what they did is Cisco basically defined what they view as hyperscale companies. So I'm not going to go through that definition here, but it's based on various factors, including sales, number of employees, and so forth. And they identified, as of last year, 24 different companies that they considered hyperscale. Those 24 companies have, as of back in 2016, there were 338 different data center locations, right? So if we take a look at this chart, it's showing the number of data centers, and then you know, obviously the growth that goes over time, and then the bar is showing here the percent share that these companies have of total installed servers. So if you take a look, 2016, they accounted for 27% of the installed server base. The forecast in 2021 is that they would account for over 53% of installed servers. So again, these guys are driving the volume and driving the market, and everybody else will end up being following. So some good data points there. Next, looking at Ethernet speeds. So this is data from Light Counting. Light Counting is a market research company that tracks transceiver shipments from the transceiver manufacturers. So like Finisar, Foxconn, people like that. And so we kind of look at that. We track this trend over the years. And if you take a look at 2019, you know, some of the things I guess I would point out. One, there's obviously a lot more options, a lot more speed options than there used to be over the last few years. And there's, you know, shift happening. The purple is the 10 gig, so that obviously accounts for the majority of the volume currently. But then you start seeing some of the other, the 25 gig is starting to ramp up. The green being the 40 gig, which has grown, and we'll dig into that more, but that stayed somewhat stable, but starting to decline. And then you see the 100 gig ramp up that I'll talk a little bit more in a second. And then 200 and 400 gig just starting, really, the green being the 200, and then a little bit of the yellow, the 400 gig. So again, just kind of the mix of where things have been and where they're going to. So as I mentioned, so digging the 100 gig a little bit more, this is also data from light counting from the end of last year. And a few things I wanted to just highlight. So this, it's grown much quicker than the forecast we're predicting. So in general, right, in terms of 100 gig. And this really looks at the top runners in terms of volume. So by reach, so the top one is the CWDM4, which is a 2-fiber single mode solution, the 2K reach. And then you've got the SR4, which is multi-mode 100-meter solution is next after that. And then you see the PSM4, which is single mode parallel, and LR4, which is the long reach duplex single mode. So you kind of see it really just started a few years ago, and 2016 and 17 seeing a pretty good ramp up continuing through this year and beyond as things move forward. The next one to look at is 400 gig. So this is data from a company called the C650 Group, another third-party market research company. And this is looking at 40 gig is in the blue, 100 gig is in the green, and 400 gig is in the yellow. A few things to point out here. So the 40 gig, as we've talked about, did kind of peak out in the 2016 timeframe, and that's starting to decline. We'll still see that being used in the enterprise space, right, as they migrate to those next speeds. The 100 gig, as we've talked about, has ramped up quite a bit over the last few years. And then the 400 gig is really looking at, you see this year in 2019, they are forecasting a steeper ramp up in volume for the 400 gig. As a comparison, the 100 gig, one reference point that the industry likes to look at is at what point did it get to 1 million units shipped? So for 100 gig, it was 7 years to the point there got about a 1 million. They're forecasting for 400 gig to be about 4 years for that same level of volume. So again, this is kind of the forecast, and we'll kind of go through what does this look like. Next, I want to talk about lane speeds. So in order to get to those higher speeds that we were talking about, the 100 gig and the 400 gig, you need higher lane speeds as part of that solution. So just kind of an overview of that. First off is the 25 gig lanes. So back in 2015, the IEEE standard, the BM standard, defined that 25 gig per lane, and that's in an SFP 28 form factor. Then just earlier this year, last month actually, the 802.3CD defined the 50 gig per lanes protocol and standard. That does have still an SFP, but it's SFP 56. And then even beyond that is 100 gig lanes. So there's an MSA, the 100 gig Lambda MSA, that actually defined what that looks like and the definition of that. So that is using a QSFP 28 form factor. There is a recent IEEE study group that was just formed earlier this year that will also define the same 100 gig lanes. So that will end up being a 802.3 CU. Again, so just this is kind of the baseline as you move forward. So next I wanted to talk about really comparing enterprise and cloud data center. So this diagram we put together actually about I think a little over 3 years ago, and it's still true today. I just kind of wanted to explain it a little bit. So this looks at if you take a look at on the left side, And I'm gonna grab my spotlight here so you can see a little bit. So on the enterprise side, on the left side, we've got really what I'm talking about is the first row is the current speeds that most users are at, and then below it are the likely options that they're migrating to as they move forward. So on the enterprise space, and just to back up one thing, what this really talks about is how the applications are different within the enterprise and data center, and that means the solutions for those are likely different as well. So for the enterprise side, most commonly 1 gig down to the server and 10 gig up, the 10 gig uplinks, and the options for them are going to the 10 gig server lanes going down, and either 40 up or potentially 25 gig up. So those are kind of the viable options on the enterprise side. We go to the cloud, it's a little bit different story, right? Most of the cloud guys are already at 10 down and 40 up. Maybe even beyond that, they're already doing 25 or 100 up, 25 down, 100 up. But they've got several choices, like I just talked about. You've got, these are the lane speeds, 25, the 50, the 100 that I just mentioned, which are typically down to the server. And these are the uplinks there, 100, 200, 400. So there's various options, and there's public information either through IEEE or otherwise. Various cloud providers are going different routes. Folks like AWS and Microsoft have basically said they're doing the 100 down, 400 up route. Facebook is one that's kind of said they're kind of going 200 gig and 50 gig down. So there's different schools of thoughts and different strategies on what that looks like. So moving forward, the other thing I want to talk about was transceivers and multi-mode versus single mode as we look at that. So this is also from light counting, and it just shows the mix of volume. And this is looking specifically 40 gig to 400 gig, obviously the forecast for that. And really what you've seen over time, that the mix is moved more to single mode, and it's pretty much stabilized around now. It's roughly 70% of the volume is expected to be on the single mode side as we move forward to the higher speeds. Next, I want to take a look at cabling, the overall cost of a channel. So obviously one of the important factors in deciding what technology to use is the cost. So what we've done is we've taken a look at the 100 gig side and the full channel cost. So this looks at some of the common technologies that are available today in the market. Again, the optics. So what this includes is 2 transceivers, one on either end, and the cabling, the fiber cabling that's part of that. And that could be either single mode or multi-mode, or a 2 fiber channel or an 8 fiber channel. Some of the things that we kind of see right away, obviously the CWDM4, which is single mode duplex, is the highest total cost. That price has come down a little bit. These are list prices, by the way. These are available list prices through public sources. And but that one is still the highest. We take a look, comparing the SR4 and the PSM4, the multi-mode and single mode options. They're pretty much priced around the same point now. So that's equaled out, and those two have been very popular over the last couple of years. If we look at the multi-mode duplex options, the SWDM4 is an option on the market. There really isn't much traction there. Not many of the switch guys offer that, but I did want to reference it here and show that it is a viable option, but hasn't been very well adopted. That one is using the OM5 cabling on that, so that the cost over that overall cost is higher. And the reason is kind of this other duplex option. The BiDi has been very popular. The overall cost is the lowest. And this one was Cisco introduced that several years ago on the 40 gig side on the BiDi, and then they introduced the 40/100 gig option last year. So it still is a low cost option from that requires and utilizes OM4 cabling. So I think that's a good reference point as we look forward in terms of the 100 gig side. So moving on, the next thing I wanted to talk about was the switches, the 400 gig switches on the market. So again, as I mentioned, there has been some very recent introductions there, and so this is looking at it from the switch. So specifically, we looked at the market leaders being in the data center space: Cisco, Arista, and Juniper. And this is from their perspective, right? The bandwidth capability. So the benefits that they're promoting with these new switches. First off, obviously the bandwidth going from a 3 terabit 1U switch to 12.8 terabit. So that's obviously quite a bit. Higher density they're seeing for 100 gig ports via breakout scenarios. And then that relates to the lower cost per port, right? Being able to get higher density, more ports is reducing the total cost of ownership per port. Before I go into the switches themselves, I will kind of do a review of the form factors that are in these switches, because that's changed over time and there's been an evolution. So I kind of just want to explain that a little bit. So several years ago, we've had SFP Plus on the market for many years, which has really been for 10 gig. Next was introduced the QSFP Plus for 40 gig, back when that first came out in 2010 timeframe. Then the QSFP 28 came out for the 100 gig modules. And now we've got another new form factor, well, 2 new form factors for 400 gig. So there's going to be 2 primary options: QSFP DD and OSFP, and I'll talk more about those in a minute. But so this does relate to the switches and understanding the options that are available there. So if we look at the new 400 gig transceiver form factors, this is a summary of the first one I mentioned is QSFP double D. So that the QSFP, just like it has before, stands for quad small form pluggable double density. So this can support up to 32 ports in 1U. It is backwards compatible to the Plus and the 28, and it will accept various different connectors, LCs, MPOs, and another CS connector. In addition, there is another option called the OSFP, octal small form pluggable. So that's also 32 ports. There is an adapter that's available that can allow backwards compatibility from QSFP ports and does accept the same connector types. The OSFP has been designed more for even the next generation, potentially 800 gigabit down the road. But there are options, and you'll see various switch manufacturers. Some are offering one or both of these. So if we start out, the first one looking at Arista, so they introduced their options, the 7060 series, top of rack switch, 32 ports, 12 terabits as we talked about, and so it does have 32 of those OSFP, or they are offering both options, an OSFP or double D ports. 32 in. From a breakout scenario, you can get up to 128 100 gig ports with this scenario. So that's what I was talking about in terms of the increased density. So next for Cisco. So just to back up, Arista, that was just at the end of the year, back in December, actually I think it was even right at the start of the year, January, that the Arista introduced that. Cisco just announced their solutions last month in February. So pretty fresh here. So Cisco has pretty much the same switch as Arista on that side, but clarifying, Cisco is only going to be offering the double D, QSFP double D ports. So from a capability and capacity, that's the same as the Arista one. It's going to be it is the 3432 switch from them. They also have a 4U chassis-based solution, total of 32 400 gig ports, or it can do the 100 gig ports as well. Super low latency with this one, but more options on that. Then also even a couple other on their 9300 platform, which has been pretty popular for them, the 9K series. So the top one showing up to 16 400 gig ports on that one, and then a combination on the other ports with the 9300 28 QSFP, and then some of the 8 of the 400 gig ports. So again, the point I want to just get across that these have been introduced, and they are on the market, and so it's really for awareness and understanding of the options that are out there. Next one is Juniper. Juniper has very little information on their public information on their site, but they basically are planning on coming out with the same top of rack switch that we talked about for Arista and Cisco. Again, they are just using the QSFP option like Cisco. Okay. So next I want to talk about transceivers. So this is a list, and we tracked this pretty closely over the years, and so the point is not to go through every one of these on here. So there's bottom line is there's lots of options. There's 13 different options for 100 gig transceivers, and so it's added a lot of complexity. But these are, whether it's in multi-mode or single mode, different reaches, different connector types. There's lots of options. One of the key things I wanted to just highlight is on about being IEEE compliant or not. You'll notice that more than half of these are not IEEE compliant. So they've been introduced through MSAs, or they're just proprietary, and that's pretty much going to be the norm for the time to come. And so that's really, I just wanted to highlight the options there. And go back here. The key point about this, again, there's lots of options available, and this goes back to designing flexibility into your network. Because the reality is you're not going to know maybe which of these 13 options are going to be used or implemented. So it's really about designing flexibility into your network infrastructure that you can be able to support, whether these 2 fiber, 8 fiber, 20, 24 fiber. There's various scenarios that require different cabling. So from a cabling standpoint, you really need flexibility to be able to accommodate any of these different options. So as we talk about 200 and 400 gig, before we go into some of the options there, I want to introduce you to some of the newer terminologies that are being used. So again, everybody's aware. So the first one is being used. So again, if I look at, you'll see in a minute, 400 gig or 200 gig SR8. SR8 is referring to, that's short reach. That is referring to 8 channels, right? 16 total fibers, and does require the use of an MPO connector. And that's the reach of about a 100-meter reach. Okay, the other one is the DR4, and that's a 500-meter reach. That is single mode, does require the MPO connector as well. And then the FR4 is a 2-kilometer reach, and that would require the LC connector. So 2 fibers, single mode for that. So again, you'll see that as we go through, but just from a terminology standpoint. So I'm going to go through this again. Let me grab my spotlight again. So these are the 200 gig options that have been introduced on the market, and you see there's not too many. There's 5 options here. The ones with, and what I highlight here is who's offering it, who's the manufacturer, what's the factor, whether there's a breakout option or not. That's really become very important for this, because that's going to be one of the primary applications. The fiber type, distance, the number of connectors, number of fibers, and the connector type. So the ones with the question marks, the reason why that's on there and it says none is because those have not been introduced yet. So those 3 options, even though they're in the IEEE standard, they are not available yet on the market. So the other 2 are likely going to be the ones. These are from Cisco, and they are proprietary options that Cisco has introduced. And you'll see that one's single mode, one's multi-mode, and they both do require the use of an MPO 24 fiber MTP. So, and I'll talk more about that. So if I look now at the next option on 400 gig, here are the scenarios for that. There's really 5 options that are out there. And again, the box ones I've highlighted, those are really what we believe are going to be the more common ones. and you've got the manufacturers. You do see most of them are breakout, and you got a lot of single mode. You've got a couple multi-mode options here as well. And one thing I wanted to highlight between number 1 and number 5 is that, because it says IEEE/MSA, and the reality is both of those have been defined in the MSAs first. That's what's been done, and IEEE is just now, I'll say, in process. You see there's a note down at the bottom here. There's 2 IEEE standards that are being worked on, that those are being incorporated in. But the manufacturers have already gone forth and introduced the products based on the MSA. So this one at the bottom is the SR 4.2 BD, stands for the BiDi. So like we were talking about before with Cisco, the 40 and 100 gig, this is basically the next gen of that, the 400 gig BiDi. And then the other single mode options that we see here, both in a 2-fiber and 8-fiber scenario. So those are really the options. You do see there's some proprietary options as well. But there are other options that are out there. I haven't included everything. Again, the 10-kilometer reach is we're not talking about. And if there's a couple that haven't been available on the market, there's a couple like an SR16 and FR8 are not yet available on the market. And there's other ones that are being worked on. So just for awareness, but I think it's general consensus that those are the primary, probably the likely high runners that we'll see. So I mentioned a couple things about MSAs. Here's just an example on the 400 gig side. MSA stands for multi-source agreements, and there's 3 of them that are out there now: 400 gig BiDi, 100 gig Lambda, and CWDM8. And an MSA is basically a consortium of companies that put together and write a specification. And here's an example of some of the companies. So it's a mix of switch guys like Arista and Cisco, transceiver manufacturers like Finisar and Foxconn, as well as large end users like Alibaba and Microsoft that are driving a lot of those developments there. So next I want to take a look at the use cases for 200 and 400 gig. As we look at the designing networks to support 200 and 400 gig, I wanted to kind of cover probably some of the key design factors from a cabling standpoint and otherwise that are going to have to come into play. The first, as I talked about before, is an enterprise or cloud company. Most likely it's going to be a cloud company, but there's different applications there. What's the reach? Obviously, different options there. Power. So power is going to be a factor. The 400 gig optics are in the 10 to 12 watt range. So that's about 3x of 100 gig. What are their current speeds, server speeds? Obviously a factor. Cost per channel, like I talked about before on the 100 gig side, what does that look like? And then also the channel insertion loss budgets, single mode, multi-mode. The single mode side, those do continue to come down a little bit. They're still 3 to 4 dB from a single mode. The multi-mode OM4 budget has been pretty consistent and is still right around that 1.9 dB frame. So that'll be good to keep in mind as you're thinking about and designing those next gen networks. So looking first use case really at the switch to switch scenarios. So what I did here, looking at, this is a channel configuration, and this is a 2-fiber single mode configuration. And what I've done here is showed, I'll start out really in the middle. So this is a base 24 MTP trunk it's representing. So just to clarify, it's right trunk cabling using MTP 24-fiber connectors. This is a solution that Leviton introduced back in, I think, 2010, so several years ago, and allowed folks to migrate to 40 and 100 gig back then, and on multi-mode initially, and then now on single mode as well. So what you see here is on both ends, you see the transceivers, the QSFP double D or the OSFP, one of those. And this is really a duplex channel, right? So, but this was supporting 400 gig FR4 or the FR8. but bottom line is this same channel can be used for 10, 40, 100, 200, or 400 gig. So lots of options for this in that application. The next one I want to talk about is 400 gig so the multi-mode solution. This is with the BiDi or the SR 4.2 solution I talked about. So this would be using OM4, same backbone cabling that we've talked about, which allows the flexibility in this case to maximize your fibers, right? Still 100% utilization. You're doing your array cords from the transceivers, the switch, into a conversion cassette, and same on the other side. This does provide the parallel fiber, 8 fiber at the equipment side. Okay, hopefully that makes sense. The other scenario is very much the same, but it's the single mode version of this. So this is the DR4 version that we were talking about. Same options. You've got the transceivers on both ends. You've got an array cord, conversion cassette, single mode cabling, and then same on the other side. Allows that flexibility and supports that migration. Again, this can be used for 40, 100, 200, or 400 gig. Lots of options there. So another one could be, this is a 200 or 400 gig option. And this was really looking at two different scenarios here. So this could be a 16 or 24 fiber channel. So the standard does allow for an MPO, the standard I'm referring to is the IEEE standard, an MPO 16 or an MPO 24. So that's why I referenced both of those. The OM4 is the SR8 or the option from Cisco, which was their 2x100. On the single mode side, it is the Cisco 2x100 PSM4. But what I wanted to highlight that these scenarios, these options do require that MPO 24 option at the transceiver. So that's obviously why you see that you're maximizing that backbone cabling and only need a pass-through in this scenario. Again, going back to the benefit of having the flexibility design into the network. So next, looking at breakout use cases. So this is probably one of the biggest use cases. There's a lot of different options, a lot of scenarios that could be here. I've given a few examples of maybe the more common ones, so just as some examples. So the first one, looking at, this is breaking 400 gig down to 100 gig, 4x100 gig breakouts. So this is the single mode for DR4, XR4 that I showed previously. So I'll walk through the channel. You'd have the 400 gig module on the end. You'd still have your 8 fiber array cord, breaking it out, maximizing 100% utilization of the fibers into your backbone cabling, and then you're breaking it out into LCs on the other side, which would plug into a QSFP28 100 gig transceiver. So again, using that same backbone cabling, do a breakout scenario on one end. Then we take a look at what does this look like from a patching standpoint. And so we created this. I kind of want to just highlight what this would look like. So this is that same top of rack switch. One of the ones we talked about is 32 port top of rack switch with the double D ports in here. You're going to plug your 8 fiber array cords into there. And those are going to go into the back of this cassette, which you could show this shows here on the rack, right? It's coming from the back, from the switch into the back side here, and that's going to plug into the transceivers here, the 100 gig. That would take up 2U of rack space in order to support 128 100 gig ports in this example. So it just kind of gives you a feel for what does that mean from a cabling standpoint, the spacing and so forth, to be able to do that. Hopefully that helps. Next, another scenario that I want to talk about is for the SR8 application. So this is using OM4, again having a breakout from a 16 fiber scenario to 8 fiber channels. And what this shows is still using an MPO24, because again, this could be an MPO24 connection with 16 live fibers in there. Breaks out here, and then still maximizing all the fibers through the base 24 cabling, and then your breakout on the other end to the 100 gig SR4 modules on the other end. So this again creates that for every OSFP transceiver here, it'll break out into 200 gig channels per that. There are other options that will become available in this scenario with an SR8, and there'll be conversion cassettes to accommodate that as well. Again, it's still, I think, questionable how much adoption level there's going to be on this particular option in terms of the SR8, but we want to just make you aware of what's out there and the options available to support that. Another one that we've seen, would likely see popular, is 200 gig down to 8 by 25 gig lanes. So this is with the Cisco scenario. They introduced the 2 by 100 PSM4. Requires single mode, does require the MPO24 single mode connection in there. That would go through your same backbone trunk cabling and break out to LCs on the other end. So in this case, it'd be the SFP28, 25 gig channels for that. So this is going to be a pretty probably attractive option to lower the cost of the 25 gig lanes for the client. Cisco also introduced the same option for the multi-mode side for SR4. So you'll see here it's a 2 by 100 SR4, does also require the MPO24 multi-mode. So this shows an OM4 cabling solution to support that. Base 24 cabling going into a cassette and converting these to SFP28 25 gig channels. Pretty straightforward there, but that could, again, that's going to lower the cost of those 25 gig ports for each one. So a lot of information there. To summarize, again, there's 400 gig switches have been introduced very recently in the last couple months or on the market. There's a lot of transceiver options that are out there for 200 and 400 gig. The breakout is really going to be probably a big application, and our job at Leviton is to educate you and present options and make that easier for you to do. So, but you need to make sure and have the network designs have flexibility to allow that migration going forward. The majority of the options do require single mode. There are some multi-mode OM4 options as well that we'll see in some scenarios in enterprise data centers or otherwise. But really, a lot of these cabling designs can get pretty complicated. And that's really why it's important to make sure you work with a trusted advisor like Leviton that can help guide you and educate you to the solutions that are options for you.
On behalf of our presenter, Gary Bernstein, thank you everyone for attending this Crosstalk Live webinar.
Thank you very much.